So we have been given an equation here. Okay, so we've been given that z squared is equal to 3 minus 4i. Now, what is z in this case? It's just some random complex number, okay? So in other words, I know that this complex number, that's what I want to find. I want to find z, by the way. Like, find the unknown thing. Find what number, complex number, when I square it, gives me 3 minus 4i. That's what the question is asking here, okay? So, how am I going to do this? Well, I know that z is just some complex number. So x plus iy, okay? So let's substitute that into this equation. So I have x plus iy, all raised to the power of 2, all squared, should be equal to 3 minus 4i. And my job is literally just to find what x and what y is. Okay? So what number, when you square it, gives me 3 minus 4i? That's the question. So I guess here we could expand this out. So if I expand this out, what do I get? X squared.
Plus 2xiy.
Good. Plus 2xyi. Yeah, good.
Iy squared.
Good. Plus iy all squared. Are you happy?
Yeah.
And that should be equal to 3 minus 4i. Okay. Let's tidy this left-hand side up. Okay. What would this thing be if I tidied it up? So I'd still get x squared. I still have 2xy I. But what would this thing become?
I squared, y squared.
Yeah? I squared, y squared. What's I squared again? Can anybody remember? It's negative 1. It's the square root of negative 1 all squared, which is just negative 1. So I get x squared plus 2xyi minus y squared then should be equal to 3 minus 4i. You happy with that?
Yep.
Okay. Now have a look. On the right-hand side, are you happy that I have an imaginary bit, the minus 4i, and I have a real bit, the 3? Okay, so I have a real bit, and I have an imaginary bit. So what I want to do is have a look now on my left-hand side. Would you be happy that I have an imaginary bit and a real bit like the same? Are you happy x squared is real, and y squared is also real? So my real bit is x squared minus y squared. That's my real bit. Okay? My imaginary bit is just 2xy. That's my imaginary bit. So in other words, if I compare left-hand side to right-hand side, I have the left-hand side, my real bit, is x squared minus y squared. So my real bit is x squared minus y squared. On the right-hand side, my real bit is 3. You happy with that? Okay. And also, if I compare my imaginary bits, 2xy on the left-hand side, and on the right-hand side, I have negative 4. So what I'm literally doing here is I'm having a look on my left-hand side, and I'm saying, I've got a real bit, and I'm adding on an imaginary bit. On the right-hand side, I also have a real bit, and I'm adding on an imaginary bit. So surely then, by logic, that the real thing on the left-hand side should be the same as the real thing on the right-hand side. And logically as well, the imaginary thing on the left-hand side should be the same as the imaginary thing on the right-hand side. That's the reason why I can set them equal to each other. Like, there's no way of having a real thing and it ends up being an imaginary. That doesn't make sense. It has to be the real thing on the left-hand side matches up with the real thing on the left-hand side, and the imaginary thing on the left-hand side matches up with the imaginary thing on the right-hand side. Does that make sense, how I got that? Okay? Now this is just a set of simultaneous equations, isn't it? Yeah? So in fact, I can just tidy this bottom equation up slightly. I could write y is equal to, if I divide by 2, I get negative 2. So it's going to be negative 2 divided by x. You happy with that? Then what could I do here?
Place the value of y in the first equation.
Absolutely. Now I know y is equal to negative 2 over x. I can place it in here, and I will have an equation exclusively in terms of y, which hopefully I can solve. So okay, let's try this. Let me create a little bit of space. So I get x squared minus, right, y squared. Well, y is just negative 2 over x. So it'd be negative 2 over x all squared, and that will be equal to 3. So sorry, I said it's going to be exclusively in terms of y. It's exclusively in terms of x. Okay? But of course, if I rearrange this, I could get it exclusively in terms of y as well. Okay, fine. So now it's just a case of dealing with this thing. So I get x squared minus, what's that thing? If I square negative 2 over x, what does that become?
4 by x squared.
Good. Positive 4 by x squared, and that equals 3. You happy with that? Okay. What can I do with this now?
X to the power 4 minus 4 by equals to 3x squared.
So describe to me what you've done there.
Taking the LCM.
So you've got rid of that denominator.
Yeah.
You've multiplied every single term by x squared. So then it becomes a lot easier to solve.
Yeah.
So if I times that by x squared, it becomes x to the 4. Times this by x squared, it just becomes negative 4. Now I times this by x squared, it becomes 3x squared. So if you multiply through by the denominator, it becomes a lot more friendly. Now just for fun, I'm going to take this thing and move him over to the left-hand side. So I've got x to the 4 minus 3x squared minus 4 equals 0. What type of equation is that?
Polynomial.
It's a polynomial, exactly. Specifically, have a look. X to the 4 and x squared. Do you notice that that power is double that power? Which means it's a type of equation called a quadratic. Yeah? It's kind of a hidden quadratic. Let me just make this clear. If I let, say, t equal x squared and substitute that in, well, would you be happy that x to the 4 is the same as x squared squared? In which case I could write that as t squared. Yeah? And that thing, well, x squared is just t, so it'd be minus 3t minus 4 equals 0. That's clearly a quadratic, so it's a hidden quadratic here. So okay, let's try and solve this. I don't think this is too difficult. So we get t, we're looking for two numbers which multiply together to make negative 4 and add together to make negative 3. So what do we get?
Minus 4 plus 1.
Good, minus 4 plus 1. Then if we solve this, we get t is equal to 4.
And minus 1.
Good. T is equal to negative 1. But you remember, we don't want t, do we? We want x. Okay, so we know that t is equal to x squared. So I've got x squared is equal to 4, or x squared is equal to negative 1. Okay, so if I solve this then, would you be happy that x is going to be equal to, is it just going to be equal to 2?
Plus minus.
Good, make sure that you take the positive or negative root of 4. Okay, and the same thing over here. Now, ordinarily, we would break down here. We'd be like, there's no solutions here, or there's no real solutions here. But we know now about complex numbers. There are solutions. What is the square root of negative 1? I. So the solutions are plus or minus 2, or plus or minus I. Is that okay? So the solutions of this equation are with x equals plus or minus 2, or x equals plus or minus I. Now all we need to do is go back and find the corresponding y. Okay, we need to go back and find the corresponding y. So we found x, now we just need to find y. Okay. Now just pause for a second. Have a look at our original equation. Have a look at our original equation. We had z is equal to x plus iy. What was the real part and what was the imaginary part?
Where?
X can't be.
Yeah.
Exactly, because x has got to be real, okay? So x and y have both got to be real numbers, which means that when we get this as a value of x, that's imaginary. It's not real, okay? Which means that actually there are no solutions there, okay? So if we're solving this purely algebraically, so for example, if I gave you these two equations, just started here, and I said solve them, then yes, absolutely, we could have x being plus or minus I. But actually, because of where we started, we define this complex number as x plus iy, where x and y were both real. So we cannot have x being imaginary. So the two solutions for x are plus or minus 2, which means that in order to find y, we just stick it into this equation here. Okay, so if x equals that, plus or minus 2, then y has got to be equal to negative 2 divided by 2, which is negative 1, or negative 2 divided by negative 2, which is positive 1. So again, I'll just write it down the other way to make sure they match up. So minus or positive 1. Okay. You notice that I've flipped that sign around to match up with this. So when x equals positive 2, y is equal to negative 1. So read the top ones. And when x is equal to negative 2, y has got to be equal to positive 1. So read the bottom ones. Make sure they match up. So therefore, my two roots of z, so z squared is equal to 3 minus 4i. I'm expecting two solutions here. My two solutions are z can be equal to positive 2 plus I, or sorry, minus I. Do you see that? Because I'm using x being positive 2 and y being negative 1. So I'm just substituting it back in there. Or the other solution would be when x is equal to negative 2 and y is equal to positive 1. So my two solutions are z is equal to 2 minus I, or z is equal to negative 2 plus I.